Hello, this will be a quick guide about using stable diffusion using Automatic 1111. The topics that we are going to discuss are the following. A little bit about installation, the startup parameters, the user interface, text to image, image to image, inpaint, where to download the models and LoRAs, and etc. I'll try to make this video as small as possible and not go into details into any of these topics. First of all, the installation, we would go to the official Automatic 1111 Stable Diffusion Web UI website. Okay, directly go to the instructions for installation. For example, it tells us it's better to do the automatic installation and avoid anything related to manual installation. For example, in Windows, we would go to, as they tell us here, we would go to this page, download the SD Web UI zip file, which is this one. After we download it, we save it into our hard drive, for example. Press extract. After extract is complete, we go back to the instructions. It tells us run, update, and then run this file. We come and press run here. Run as an administrator. Sometimes it tells us something like this, more info, run and away. It will start downloading the Automatic 1111. So it has downloaded it. Come here, we see that Web UI is here. Now, if we have the models downloaded, we don't have to press run immediately. After this, we could press run. So it will start downloading the Automatic 1111. Now we wait till the installation is complete. Alternatively, we could follow these instructions as well. They both work by installing Python 3.10 version. We don't have to install any newer version because we want Torch to be supported. Install Git, which is Git for Windows, for example. Then we use run command and copy this line of code like this. Copy and paste the command line, enter, and it will the Automatic 1111. Then we run Web UI path from the installation directory. This is this is another method. There are other methods for installation like in Linux, etc. We just have to follow the instructions step by step. The first time we run Automatic 1111, it takes time. Each time we want to use a new feature, it will download that feature. So sometimes, for example, if you want to use controlnet, it will download controlnet models, for example. If you want to use a certain upscaler, sometimes it will then download the libraries and files related to that upscaler, so it takes a while to complete. Now, once the installation is complete, we can close the window. It's possible, or run it immediately. However, I suggest to close and update the Web UI user path file. Now, by going to this file, initially it is like this, so it's better if you have NVIDIA to add Xformers, for example. Xformers will make the image generation much faster. It's also recommended to add auto launch. This will allow the Web UI to run automatically in the browser without having to copy the URL or the address. Also auto check to check if there's a newer version available. It's also possible to add git pull. This will allow to automatically update anything that's missing. For example, automatically update the Web UI in case there's a new version. Okay. Now, when we launch the version, now it will check for the updates. Then it will run automatically in the browser. So when we run, it tells us the version, the Torch, the Xformers version, etc. If we want, this is how it initially looks like. It doesn't have any models. It doesn't have many extensions. So if you want to install more models, we would have to go to Civit AI and choose the best model that's suitable for. Now, to add more models to your Stable Diffusion Web UI, you would go to Civit AI, for example, or Hugging Face. We choose the model that we want. Okay, then we press download and save it in this location where the Web UI exists, Web UI models, Stable Diffusion. So we come to this folder. It's the Stable Diffusion inside models. Now, if we want to download a LoRa, we would put it in a LoRa, in the LoRa document. If we want to download like chorus, for example, we put it here. If we are downloading an embedding, such as textual inversions, we put it in embeddings folder. Now down here, there's something called a blur mature content. So mature content would contain nudity, etc. So we turn it off if we want to see all the content, okay, and the different types of models. Chill out mix is one of the most popular ones. Now, there are many types of stable diffusion models. The pruned version, it does not give so great results often. So people often use Rev Animated for something like something anime-like. Photon contains pretty images. Realistic Vision version 3, for example. Now, in the upcoming days, there will be Stable Diffusion SDL XL, which will be officially released. Now it's leaked. This might render all these models to actually become kind of obsolete, because there will be, it's most likely that these models will become slightly weaker. So these models need to be trained on the new model with the images that existed, that were used in training these models. So here we can choose what we want to look for, such as checkpoints, which are the like SD 1.5. If we want to look for a LoRa, we could uncheck this and look for a LoRa only, okay, and go about it and select the file that we want. For example, if you want to have this LoRa, for instance, we go to it, then we download it and put it in the LoRa directory inside Stable Diffusion Web UI Models directory. It's possible to install extensions by going to Extension tab, Available, Load From. This will display a list of all official extensions available to Automatic1111. If an extension is not here, you can install it manually as well. However, we often prefer to use these extensions only. For example, if we want to install controlnet, we would search controlnet and go to controlnet and press install, for instance. If we want to download Rube, we'd go to Rube and install. So after we install the extension, we press update, apply and restart, or it's better to close and restart all over again. So once we download our extensions, the user interface will change. So regarding the usage of Automatic1111 for Stable Diffusion. So in text to image, here we write the prompt that we want. For example, a photo of a woman with a mountain in the background, for instance. Now here we would write something that we don't want to see. For example, if we don't want to see nudity, for example, we would write nude, naked, deformed, for instance, bad hands, etc. Then we press generate. We control the size of the output here. So we get something like this. If we want a better image, we would put more like masterpiece, best quality. Now this command will read the last generated image. So for example, if we closed Automatic1111, then we came back, then we press this, it will actually bring us the most previous command, okay? Now if we want this, for example, to save it, we think that it's good, we would press save and give it a name, for example, so that next time we would come here, negative, for instance, it will append, okay, it will append the command here, for instance, okay? Now there's show and hide here. It will allow us to use different files such as LoRAs, for instance. Just by clicking here, it will be added to the location. If we want to use a LoRA, for instance, just click on it and it will appear in this location. It will start with LoRA, then the name of the LoRA and the weight of the LoRA. Now LoRA can affect the produced image very greatly. This is why we need to be very careful about the weight. For instance, we could use 0.3 for some cases. We come back to the user interface. Now here we choose the sampling method. There are many sampling methods, Euler A and DPM++2M. Keras are very fast and very effective. They are the most used two methods. Now this one, for example, here it will take almost double the time Euler takes, but it produces slightly more realistic images. So I will present another video about the comparison between the different sampling methods. Now here we choose the size of the photo. For example, we put 768, and the generated image will become like this, for instance, something different. If we want to do something to get something more similar, we would freeze the seed. Now here, for restoration of the faces. Now for restoration of the faces, for example, when we have a face of a person, sometimes the face does not look very well. So if we put restore faces, it will fix the eyes, for example, and the facial characteristics, but it often changes the character so much, so it will become very different. It's better not to use it if the face is good or acceptable. Now high res will allow us to get a higher resolution of this picture. Like this, for example, we would choose the upscaler method, for example, ultra sharp or anything else. We would choose the steps, the number of steps. For example, here we generated using 20 steps. Here we would just choose, for example, 10. We choose the denoising strength. This denoising strength, if it's very high, it will change the upscaled image a lot. If it's very low, it will change it slightly, but it will increase the details. So I would recommend that this value is often to be, for example, 0.2 to 0.5, so that we don't change the picture that much. Then, for example, here we upscale by 2. This will make the generated image twice as big. So, for example, with high res will take slightly more time to complete. So here we change the CFG scale. This scale, it is like the connection between the description and the produced image. The higher it is, the more the image will resemble the prompt. If we want more freedom, we would reduce this value. So often I would use 4, for example, for more creativity. 7, approximately 7 is good for a more constrained prompt, for example. Now here, by default, the seed is -1. This means that each time we generate an image, something else will be produced. Now, however, if we want to produce the same, we would want to continue working with the same character, for example, we would fix the seed. So fixing the seed means that the next generation will resemble this picture slightly. Okay, all will be the same character. Now there are other stuff like controlnet, for instance. I will not go into details with this one. However, for example, if you want to have a character, for example, that is standing, for instance, we would go to open pose or copy some pose from here. We could copy it like this, for instance, or send to image, etc. Then come here, for example, we would choose open pose, for instance. Now, since I have the open pose already, I don't have to use the full pose. However, if I have a picture from a certain location on the internet, we can copy it here and it will detect this skeleton. If I have the skeleton already, so I don't have to use a preprocessor and just use the model immediately, which is the controlnet open pose. We could use something like this, just resize, for instance, or resize and fill. Then we would press generate to see the output. Now, if we have a picture of a woman, for example, here, we fix the seed, we would put the pose here, we would put enable, then generate. The generated image should be like this skeleton, for example. But we should change the height, for example, till 768, that would be better. So when we press enable, we fix the seed, we generate, we get something like this, which is basically the same pose as here. There are different types of preprocessors, such as Canny. So what Canny does is something like this. We assume that we have a picture online, for instance, like this one, and we want to use this picture. We would copy this picture, we would go back to controlnet, then we paste it here, and the Canny preprocessor, it will be basically try to fit the picture in something like this. So we pressed enable, then we generate and see the output. Now we see that the picture has actually changed, but it gave us something similar to the pose that was here. The Canny will actually try to fit the hair, the body, everything in this picture and try to create something similar using controlnet. So these are the basic tools here. There's also something called script, for example. For example, if we want to compare different scenarios, we'd use script XYZ, for instance. If we want to compare different steps for the different seeds, for example, we would put the seed, first seed here, second, etc. If we want to change anything here, we can change it and it will create an XYZ ledger, for example, like this. So for example, if you want to compare these seeds, we would just press generate and wait for the output. So it will basically give us something like this, which we can compare the different versions and choose which one is more appropriate. Now we have something called batch count, which will allow us to generate new pictures. Okay, a batch size, it will use the same seed. This one will use, for example, the same seed, but it will have slightly more some variations. Now, often if we have a large VRAM, we would increase batch size. If we don't have a very large VRAM, we would use batch count, because this one will generate the pictures one by one, while batch size will try to generate all the pictures at the same time and make use of the GPU. Now, the second tab is called image to image. Now, the second tab is image to image. It's possible to take this image to image. This is like processing of images based on description of the image. Now, this command has copied the same command here. We could also change it, play with this, with the generation, change the size, change the details. Now, it's also possible to bring a picture from the internet and place it here, so we don't have to use the same picture generated in text to image. We could see, for example, the generation of this picture, how it will be produced here. So it's basically almost the same, because, however, if we change the denoising level, the picture will change much less. We see that here is different from this one. So if we change the denoising level, it will become more like it, but slightly different. Okay, we could this process could allow us to add more details and change the image slightly. It also allows us to bring images from the internet, for instance. If we put this picture, we could actually put it here and press interrogation. This is like interrogation of the picture. What does this picture contain? So based on the interrogation, this is the description of the picture. We could also use the same settings here and press generate and see how this person will be generated as an anime picture, like an anime, based on this description. So it provides a slightly different picture. If we increase the denoising level, we would get a lot more change in the picture. It will be something different. So image to image is basically trying to change the details of the same picture, or a conversion of the picture to another model using the same picture. And we could also change the prompt in this location. Now, for example, there is also something called inpaint, which allows us to inpaint certain features of the image. For example, we could set this one to inpaint and choose something to add. For example, if I want to have a bird in the sky, we could use something like this and just press bird, write bird in this location. Now, since I just want the bird to be located here, we could also create latent noise. There are different options here. Inpaint mask, I just want to inpaint the mask area, which is I just drawn here. If I want based something slightly different, for example, if I want to change the eye slightly, I would choose original. If I want something entirely new, I would put latent noise. I could draw based on the whole picture or only masked. I could choose the size of the bird that I want to generate, 512 by 512. I could press generate, for example, to see the bird. Now, we don't always get what we want immediately. Sometimes we do, sometimes we don't. So we might have to do multiple generations. Okay, this looks good, so I can drag it down here and start working with this one. Now, for example, if I want to change the eye, if I want eye, for example, I could say something like an eye, or just use the same picture here and use original. I could change the denoising level so that the change will be just a correction. If I use a high noise denoising level, the change will be significant. For example, in this case, only masked. We could also draw the whole picture. We can see that the eye has changed. Now, for example, we could change the both of the eyes at the same time. So this will try to produce a different type of eyes for the character, for instance. So now the eye has become green, for instance. I can drag it and drop it down here again. Now there's a tab here called PNG info. This allows us to get an image that we have generated earlier and extract the details of the generation. For example, this picture was generated using this command and this command and these details. You can find the seeds and various information. So we can send this text to image once again and regenerate the same picture once again using generate. So this allows us to read the information of this image and regenerate it once again. Another tab here is the extras. It allows us, for example, if you want to resize a certain image, we would come here, for example, into this folder, drag and drop this image. I want to resize it by, for example, upscale it by 2. It will become twice in size, twice as large. So we can choose the upscaler. Then if this picture has a face and we want to apply face restoration, for example, if the face is not good, if the face is good, we don't have to apply it. If the face is not good, for example, the eyes are not looking so perfect, so we can increase the code former or GFP GAN to in value so that it can restore the face. We could also apply batch processing. For example, if I want to resize all the pictures in this folder, I would copy this folder, paste it in this location. I want to resize it into another folder. For example, here, I would choose the resize, then generate, and I will resize all the pictures in that folder. Now, there are other tabs that we could use. For example, if we installed Dreambooth, for example, for training, Open Pose Editor, which allows us to edit poses or just copy poses from the internet. Okay, and many other features in Automatic1111. These are the most basic features in Automatic1111. We could also see some settings up here, but they don't appear in all Automatic1111 web UIs. We have to set the settings. We have to go to settings to display the VRE. And in some cases, the VRE is already included, so we don't have to actually use it. I'll just keep it automatic. Okay, clip skip could be used as well. In most cases, we'll use clip skip 1 or 2. This will be actually the more clips that we skip, the faster the generation will be, but the less accurate it will become. Often we use only clip skip 1 and 2 because this is like skipping a layer from the Stable Diffusion neural network. So the more layers we skip, the less accurate the results will be. Now, to add more settings to the user interface, such as the VRE or VRE or clip skip or extra settings, we'll go to settings. For example, there are many settings here. For example, if you want to add another control net, we'll go to control net settings and change the number of control nets to display, for instance, 2 or 3 or more. If we want to change the user interface, we would go to something related to user interface. So this is the user interface. I want to display, for example, the SD VRE so that I can see this one here. So basically, we would write what we want, VRE, etc., and we select it. We choose the settings that we want to add. So basically, this is all related to settings and what we display in the graphical user interface. So there are many features in Automatic11, but this is a general overview of Stable Diffusion and Automatic1111. And have a good day.